Okay, hi everybody. So, given some function on Rn and a subset of Rn, briefly describe numerical integration. So, in words, to integrate, or to numerically integrate, f, and we say to integrate f on the subset A, is to compute a weighted sum. A weighted sum of what? Of the values of f weighted by the volumes of pieces. So first we have to break A into pieces. So break the whole subset A into pieces. And I'll draw it in a little picture right now. Let's pretend that we were in R2 and this was A. Here's our set A. I'm going to break it into pieces. And I'm going to pick a point on each piece. So maybe this is, I've broken it into 5 pieces, and I pick a point on each piece. So break A into pieces, A1, A2, A3, and pick points on each piece. So maybe I'll call them x1, x2, x3, on each piece. Then sum the values f of xi. So at each of the points, take the value of f and sum it up, weighted by the volume of ai, of the ith piece. Okay, so in a formula we might write that we take, what is it? The volume of the ith piece is the weight, it's a number, and then multiply it by the number f of xi. And just compute a sum of all those things. And that's basically the integral of f, so approximately. Yeah, so I mean, literally this sum would be like the volume of a1 times f of x1 plus the volume of a2 times f of x2 plus the volume of a3 times f of x3, etc. That's what this symbol means. Okay, so part B, numerically approximate the integral of f over a, when a is the subset between 2 and 5 on the real line, and f just squares everything, x to x squared. And it says use at least 4 pieces. Okay, so part B. So I'm gonna let's first draw a picture. Okay, so now here we are. We're not in R2, but we're rather in R1. And we have from 2 to 5. So let's break this into some pieces. How about, well, here's like 3, and here's 4. So how about this will be one of our pieces, this will be one of our pieces, and then maybe this will be one, because we have to break it into 4, so I need 2 more pieces, so I'll do these 2. So that's like A1, A2, A3, A4. Okay, and so in formulas, I would say, like A1 is from 2 all the way to 2.5. A2 is from 2.5 all the way to 3. That's right there, that interval. A3 is from 3 to 4. It's every number between 3 and 4. And A4 is between 4 and 5. Every number between 4 and 5. Okay, so then I just need to pick some points on each piece. So how about we'll let x1 be 2. That's that point. How about x2, we can have that be 3, just to make these numbers easy. x3 can be 4. I mean, it might make more sense to put x3 right in the middle of a3. But 3.5 is a little... I'm just going to choose 4, and then x4 can be... Okay, fine. I'll choose 4.5 for x4. I just need to choose a point on the piece a4. Okay. And then what do I get? Well, I just compute this sum. So the integral on 2 to 5 of f, which you might write as the integral of 2 to 5 of x squared in single variable calculus. Well, it's just going to, well, it's not going to be equal. It's going to be approximately equal because we're numerically integrating. Numerical integration is approximate. And what is it? Well, I just take the volumes of each piece and use those as weights when I add up the values of the function. I'm adding up the values of the function. Okay, so what are the values here? I just take each of these numbers and square them. So like 2 squared plus, and then 3 squared plus, and then 4 squared, and then plus, and then 4.5 squared. And then that's not it, because I have to weight them. It's not just a sum of the values. There's infinitely many values, so we weight them by the volume. And so the volume of A1 is just, well, it's just 1/2. That's the volume of A1. The volume of A2 is also 1/2. The volume of A3 is just, it's length 1, so its one-dimensional volume is 1. And the volume of A4 is also 1, because it's one-dimensional volume. It's also called length, is 1. Okay, and this is my answer. Some number. I add up the values of the function. You know, the function was x goes to x squared. That was the function. So I take each of these points and I square them, and then I add them up, but with weights by the volume of each piece. Okay. That's it. So, good. I was just quizzing myself because I had done this before. Let's look at my other, so you can see I chose different points. Okay. See you next time.